Hello Year 11, welcome to week 16 of our revision. This week we are looking at hexadecimal and units of data. Can you make sure you have sheet 3 with you, please? Sheet 3. We did the left side last week, we are looking at the right side this week, hexadecimal and units of data. Have this in front of you, ready to complete, please. Okay, hexadecimal. Let's have a quick recap, see what we can remember. So if you remember, we've talked about the fact that humans count in denary, base 10, which go units, tens, hundreds, thousands. And last week we looked at binary, which is the computer numbering system, made up of zeros and ones, base 2, and it goes 1, 2, 4, 8, 16, 32, 64, 128. It doubles. The columns double. Now, one problem with binary numbers, it can take a lot of binary numbers to record denary numbers. For example, you can see, look, 6.5 million in binary is incredibly long, 1100, 1111, etc. Okay, and the bigger you go, the bigger the binary number goes. So there's a big problem with that, trying to store and write those down. If you're writing it down, it'd be harder for humans to remember, and there's more chance of making mistakes when you're writing those numbers in. So, is there a different way? Yes, there is. There's an alternative called hexadecimal. Hexadecimal is base 16. So we've gone from denary base 10, binary base 2, hexadecimal is base 16, which means there are 16 different possible values we can store and use. It goes from 0 to 9, and then A, B, C, D, E, F. So 16 different values in total from 0 to 15, but the values in hexadecimal go from 0 to 9, and then instead of 10, A, B, C, D, E, F. That's the first main thing to remember. So if you look at the columns, it would look like 1, 16, they go up in sixteenths. Okay. One hexadecimal character is the equivalent to 4 bits. So if you have a look at this table on the right hand side here, a 4-bit binary number is equivalent to 1 bit in hexadecimal. Okay, so the number 10, for example, 1010 in binary would be equivalent to the letter A, or 0110 would be equivalent to the hex character 6. So why use it? Why use hexadecimal? It's simpler to remember large numbers in hexadecimal, much shorter. So a simple hex code like this would represent the binary number, all of that, much shorter indeed. And that can be used for things like color codes, hexadecimal color codes when you want to remember a specific color. Less chance of input errors when you're typing it in, because again, they're much shorter, less chance of writing an error in. And it's much easier to convert between binary and hex than binary and denary, much quicker, and we'll see how now. So how do you convert from binary to hex? Well, let's take a binary number such as this, 101010111. First thing you do is chop it in half in the middle. Turn it in from a byte into 2 nibbles. Then we work out the 2 nibbles separately. We put the columns above, 1, 2, 4, 8, and then 1, 2, 4, 8. We then work out what that would be in denary, well, 5 and 7. Finally, we change it to hexadecimal. Is there a 5 in hexadecimal? Yes, there is. Is there a 7 in hexadecimal? Yes, there is. However, if this number here, for example, was 10, we look up here and go, oh, there is no 10 hexadecimal, so it's A. How about going the other way? What if you've got to convert the hexadecimal number back into binary? Well, the first thing we do, we take our number and we chop it into 2 parts, chop it down the middle. So we chop into 2 nibbles, 7 and D. We then will work out what that is in denary. So 7 is 7, D is 13, remember. 10 is A, 11 is B, 12 is C, D is 13. We then simply work out the nibbles. 1, 2, 4, 8, 1, 2, 4, 8. Well, 7 would be 0, 1, 1, 1, and 13 would be 1, 1, 0, 1. And then we put them back together again. The key thing to remember here, is you are doing them separately. 1, 2, 4, 8. 1, 2, 4, 8. If you can do that, the rest is easy peasy. On the sheet, make sure you fill in the table, write the binary numbers and the hex numbers here and here, and then do this example. Remember, chop it in half. Work them out separately. 1, 2, 4, 8, 1, 2, 4, 8. And here, chop them in half, work them out separately, put them back together at the end. Show your workings. Make sure you write in here the 1, 2, 4, 8. Otherwise you may make a mistake or you miss a mark in the exam for workings out. Off you go. Okay, hopefully you've had the time to pause the video and complete this. Let's check your answers. So, filling in the table first. The binary numbers you should have are on the left hand side, binary numbers. Remember, it always starts 0, 0, 0, 0, and then we just increment it as we go along. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, etc. All the way down to 15, where all the columns are turned on. Our hex numbers. Well, remember, it goes from 0 to 9, and then instead of 10, it goes A, B, C, D, E, F. In the exam, write it out. Just write out 0 to 9, A to F to remind yourself. Easy. Converting our binary numbers into hexadecimal. First thing we do is chop them in half, remember. Write it out in the exam. 1, 2, 4, 8. 1, 2, 4, 8. Once we've got that, our left side here is 14, and our right side is 7. Is there a 14 hexadecimal? Remember our table here? No, there's not. 14 is E, and is there a 7? Yes, there is. So it's just 7, and our answer is E7. Other way around, EA. So E, well, we've just done this, so this should be easy. E is 14 and A is 10. Now we need to convert it back into binary. So our columns 1, 2, 4, 8, 1, 2, 4, 8. 14 would be 1, 1, 1, 0. And 10 would be 1, 0, 1, 0. Put them together and there's your answer. Checking your answers, purple pen, now. Okay, and finally, units of data. So we've looked at binary. Binary is arranged in units. They go up in size. So remember, everything stored on a computer is in binary. A single 1 or 0 is called a bit. 4 1s and 0s is called a nibble. 8 1s and 0s is called a byte. And from there on, we have kilobytes, megabytes, gigabytes, terabytes, petabytes, etc. How does that arrange? How do they correlate? Well, remember, a bit is a single 1 or 0, nibble is 4 bits, byte is 8 bits, and from there on, it is 1,000 of the previous unit. So a kilobyte is 1,000 bytes. A megabyte is 1,000 kilobytes. A gigabyte is 1,000 megabytes. It's always 1,000 of the previous unit. Terabyte is 1,000 gigabytes and petabyte is 1,000 terabytes. 1,000 of the previous unit. And remember, a byte is big enough to store maybe one letter. A kilobyte is big enough to store a very low quality image. Megabytes is short music or music files or video files. And gigabytes are for larger movies, videos, computer games, things like that. And terabytes is loads of space for storage, basically all the files in school. On the sheet, write out the units of data and how much of the previous unit they are, just like in the previous slide. See what you can remember. Okay, time to check your answers. Let's see if you got this right. You should have a table, something a bit like this. A bit, 1 single 0 or 1, nibble 4 bits, byte 8 bits, kilobyte 1,000 bytes, megabyte 1,000 kilobytes, gigabyte 1,000 megabytes, terabyte 1,000 gigabytes, and petabyte is 1,000 terabytes. You do need to know in the exam how to convert between the two. We'll cover that in revision as well. Okay, and finally, for this week, as always, revision quiz 16. This will test some of the things we've covered today. Make sure you check and get 100% by the end of the quiz. Ready to show me a lesson. Have a good week.